the papers. Chunky exam, 2 hours 40 minutes. I really don't understand why they don't just split it into 2 papers like EdXL and AQA, and pretty much every other exam board do. But yeah, this is what they decided to do, so yeah, we're going to be splitting this into maybe 2, maybe even 3 parts, but I know we'll probably be able to get through the entirety of Section A in this video. Section A is like the first 34 marks. It shouldn't be that bad. Yep, so let's get through it. I'm going to be talking through the questions, so it might take me a bit longer, but yeah, let's get into it. So first question is just I'm going to be using our standard summation formulas. So we have the sum from r equals 1 to n of 2r squared minus 1. So that's going to be equal to, we split this, so we can apply our standard results, r squared minus the summation of n r equals 1 of 1. And now we can say that there's going to be 2 big brackets, and then use our standard result for r squared, which is going to be n over 6, n plus 1, 2n plus 1. And then we can say that summing 1 n times will just give us n, and that will not be in the 2, so I should close that. And then we're going to get n over 3, and I'm going to factor this out, n plus 1, 2n plus 1, and then minus 3, since we have factored out a third as well. And we get 2n squared, n over 3, 2n squared plus 2, 3n, and then 1 minus 3 minus 2, which is going to be n over 3, and then factorising this, we're going to need 2n, we're going to need, we're going to need a 2n, and then we will need maybe minus 1, and then an n plus 2, 2n squared minus 2 minus n plus 4n. Yeah, that seems to work. And so there, what I'm just doing is, since 2 is prime, that needs to be a 2m, and that needs to be an n. There's no other combination there where you can multiply 2 whole numbers to get 2. And the same with this. So it's really just about trying to experiment and see which way the signs go around, so whether this is a minus, this is a plus. And yeah, but you can just do that by inspection basically. So yeah, that's your final answer, and we'll move on to question 2. So question 2 is the plane x plus 2y plus cz equals 4 is perpendicular to the plane 2x minus cy plus 6z equals 9. C is a constant, find the value of c. So if the planes are perpendicular, so we have like 2 planes crossing here, then their normals will also be perpendicular. And if we know they're perpendicular, then n1 dot n2 must equal 0. And so we know the normals are just the coefficients of our planes, so we can say that's 1 to c dotted with 2 minus c6 is going to be equal to 0. And then so 2 minus 2c plus 6c equals 0. So 2 equals minus 4c, and c equals minus a half. So that is a nice 3 marks right there. Question 3. So question 3a is a verified question. Let's see, matrices A and B are defined by A equals 2. A equals 3, 1, 2, 3, 1, 2, 1. B equals k, 1, 2, 0, where k is a constant. Verify that this is true. So let's start by working out AB, which equals 3, 1, 2, 1 times k, 1, 2, 0. I don't know why I put plus there. And then that is going to be equal to, so it's a verified question, so we'll try and show how we're working here. So 3k plus 2, and then we're going to get 3 plus 0, again showing 0 because it's a verified question. Then you're going to get 2k plus 2, and then we're going to get 2 plus 0. And then so depth of AB is going to be equal to 2 times 3k plus 2. So I'm just multiplying these. and then multiplying these, minus 3, 2k plus 2 is going to be, so 2 times 3 is 6, minus 3 times 2 is 6, so they're going to cancel out. 4 minus 6 is going to be minus 2, so it's going to be minus 2. So we're going to get the minus a half, and then 2, so this is going to be AB minus 1. The inverse of AB is going to be 1 over the determinant, negative a half, and then we're going to, this is just something you can kind of remember. You should just remember this because it will save you a lot of time. So for a 2 by 2 matrix, you just invert these two. You invert this one, and you make this one and this one negative. Yep, so we just swap these two around and make these two negative. So we're just going to swap 2 and 3k plus 2 around, and then we're going to make these two negative. And that is how you invert a 2 by 2 matrix. So I just recommend remembering that, so you can remember it in the form. If that's A, B, C, D, then you're going to get D going to where A was, A going to where D was, and then these stay in the same place. You just add a negative sign on there. So that is our AB minus 1, and then B minus 1, A minus 1. So B minus 1 is going to be equal to, well, we have k times 0, 1 over, and then k times 0 minus 2 times, and then we're going to flip these, so flip that and flip that, minus that, a minus 1, so if we do 3 times 1, 1 over 3 times 1 minus 2 times 1, that'll give us just 1, and then we're going to get 1, 3, minus 2 minus 1. So we can say that we have minus a half times 0 minus 1 minus 2k times, and that's just 1. The determinant that's just 1. So we can say that's just 1 minus 1 minus 2, 3. Now what we can do here is we can multiply these out to get 0 plus 2, and then we're going to get 0 minus 3, and then we're going to get minus 2 minus 2k, and then we're going to get 2 and then plus 3k, which is equal to AB minus 1, I'm pretty sure. Yeah, so these two here are equal. So it's true. This always should hold true, by the way. Like, so you want to be getting that this, it's a verifier, so you know this always must hold true, right? So yeah, you want to make sure you get that. So that's 3A. 3B, investigate whether A and B are commutative under matrix multiplication. So, if they're commutative under matrix multiplication, AB will equal BA. So we already know AB was equal to, so 3k plus 2, I'm just going to rewrite it down here, 3, 2, and then 2k plus 2. So we know AB was equal to that, so now we need to work out BA is going to be equal to K1, 2, 0, 3, 1, 2, 1, which is going to be equal to 3k plus 2, so that checks out, and then k plus 1, and then so this wouldn't work for all k, however maybe we can get it to work for a specific case of k, where k would equal 2, but we're going to need to fill it out first to see if that's true. So then we need to do 2 times 3 is 6, and then so that's going to be 6, and then you're going to get 2 times 2 times 1, so that's going to be 2. So this means that k plus 1 must equal 3, and 2k plus 2 must equal 6 for us to get AB is equal to BA. And so 2 works for that, and 2 works for that. So k equals 2, they are commutative. However, for every other k not commutative. So yeah, if k wasn't 2, then these would not be equal, and that means that AB would not be equal to BA, hence they wouldn't be commutative. If you didn't know, I should probably mention this, commutative means that they are, the order doesn't matter, so AB is equal to BA, or say for example 5 times 3 is equal to 3 times 5. So normal multiplication is commutative, but matrix multiplication isn't always commutative. Yeah, if you're doing extra pure, you'll be quite comfortable with that probably because you do group theory, but if not, then that's what it means. So in this question, you must show detailed reasoning, so no calculator I'm guessing because it looks like it's an integral. Figure 4 shows the region bounded by the curve y equals sec a half x, the x-axis, the y-axis, and the line x equals pi over 2. Well, that is a mouthful. Figure 4 is there, that gives us a bit more information. This region is rotated through 2 pi radians by the x-axis, so it's the volumes of revolution. Find in exact form the volume of the solid. Okay, so because we're revolving around the x-axis, we are going to use that our radius is y. So imagine if you want to, like, because you're not given this a formula booklet, if you want to know how you can work this out, you can think, well, if I have this as my graph, right? I want to take basically there's going to be small circles at each step along the x-axis being generated as I revolve this shape. And so these circles are going to have a radius equal to the height of the function at that point, which is just going to be y. And so it's a lot easier to visualize in 3 dimensions. I might actually make a video showing that if that would be interesting. But yeah, so we are just going to get obviously our radius is the height y, so our formula is going to be pi times the integral of y squared dx, where this integral is basically summing up these small circles over the interval. And so our interval is pi over 2 and from 0. And so, yeah, so we're going to want to just integrate that. Doesn't seem like there's much else to this question, to be honest, which is nice. Just a nice 3 marks, I guess. This entire section A is really just, do you know your stuff? Have you revised it? There's not really much, you know, extra thinking needed for these questions. You just sort of apply your knowledge. So for this one, we can use d over dx. Yes, this is actually an A-level integration. So d over dx tan x equals sec squared x, right? So this doesn't even need you to apply a knowledge of further trig, which is nice, or further maths trig subs, which is cool. So pi times, and then so our integral will become pi, and then 2 times tan of x, half x, I should say, from 0 to a half, and pi over 2, sorry. And so we can then just sub pi over 2 into this, so pi 2 times tan of pi over 4, and then because it's detailed reason I'll just shove in this 0 here for good measure. And so this is going to become pi times the tangent of pi over 4 times 2, which is going to be just 2. Yeah, 2. So it's just 2 pi. Nice. So yeah, this is just remember that they can ask you about A-level stuff, I guess. Just make sure you're confident on that, but I'm sure if you're doing further maths, your A-level maths should be sound. And if not, then I don't know, make sure you get on that, I guess. Using the Maclaurin series. Ooh, Maclaurin is quite early here. Usually I feel like they show up around question 10 mark, but here it's showing up a bit earlier. For cos 2x, for small values of x, that is true. So, do we get cos 2x in the formula booklet here? Yeah, we do actually. Okay, this simplifies this a lot. So, yeah, okay, so just going to use the Maclaurin series for cos 2x, for cos x, and then we're just going to sub in 2x into our expressions. So 1 minus 2x all squared over 2 factorial, and then plus 2x to the 4 over 4 factorial. Make sure you're squaring the entire expression, including the 2, obviously. And then minus, and then 2x to the 6 over 6 factorial. It's nice that they actually give you that just straight off the bat. You don't need to do any differentiation. But it's always good to remember this comes from doing the derivatives of cos 2x. So f of x equals cos 2x. And then say f primed of x would equal negative 2 sine 2x, which would just be 0, and then so on and so on. Oscillating would give you this. Right. Anyways, moving on. This is going to give us an approximation. An approximation for cos 2x. Now, so we have cos 2x. And we want sine squared x. So if we want sine squared x, we can use this identity. Sine squared x equals half minus a half cos 2x. Now, if you think I'm pulling that out of thin air, this comes from the double angle identity. So cos 2x equals cos squared x minus sine squared x. You can just start off with this and get to this, but it takes so long, and this identity here appears so much in polar coordinates and so much in integration in general. I'd recommend just learning this and also cos squared x equals a half plus a half cos 2x. I'd recommend just learning those ones off by heart, because it'll save you so much time in these questions, honestly. So you can start off with this and get to here, but I'm just going to state this because I think you should learn this. It's just very useful. Which you probably have, hopefully, off by heart. Minus, so we're going to then sub this Maclaurin series into our formula here. Talk about what sine squared x is. So that's going to be minus 4x squared over 2. I'm not going to do too much simplifying all at once because I could, make a mistake there. Over, that's going to be 24 minus, and then 64 x to the 6 over 720, and then so we'll do a half minus a half, so they will cancel, and then plus x squared, since we factor in that a half there, and then also factor in the minus, and that's going to become minus 16 over 48, which is a third x to the 4, and then that's going to be plus 64 x to the 6 over 1440, which I'm just going to quickly look into this calculator here, which is going to be 2 over 45, so that's going to be plus 2 over 45, x to the 6th there. These are going to cancel out, and we're going to get a equals 1, b equals minus a third, and c equals 2 over 45. So there you go. That is quite a tricky question, I feel like. Not tricky, but quite a lot of room for errors if you didn't know the identity. There's lots of like shortcuts for this question, right? Because you have cos of x in the formula booklet, and also this identity. So you could do this question really, really fast for 5 marks, to be fair. Just got to be careful you don't make errors of the factorials and the minus sign, the half, which could slip you up. Right. Moving on to question 6. Let's see how far we are. We're close to being done now, section A. We've got an improper integral here. First, what we're going to do is we're going to consider the integral of a 2 to a of 1 over 4 plus x squared. I'm not going to mention the limit yet, because then I just have to write it through all of my working, and that's going to waste time. I'm going to take the limit at the end. You guys consider that, and then it's equals, right, so 1 over 4 plus x squared, that is a standard result, that's our arctan, so that's going to be 1 over 2 arctan of 1/2, and that's going to be from a to 2, so we can evaluate that as a half arctan a over 2. There's detailed reasoning as well, so minus a half arctan of 1. And then what we can do from that position is we can then take a limit. So the lim is a tends to infinity of a half arctan of a over 2. Well, we know that, hang on, actually I should probably say this first. We know that as a goes to infinity, arctan a over 2, a half arctan a over 2 goes to, wait no, arctan of a over, why is it going on, bro? Why is something getting rubbed out? Arctan of a over 2 goes to pi over 2. So this is going to be equal to pi over 4, and then so we have pi over 4 minus pi over 4, wait, which is 0, that can't be right, hang on, finding something wrong here. Oh wait, yeah, okay, so there's a half of pi over 4, which is pi over 8, which is equal to pi over 4. So yeah, just remember you've got these factors here, because that's what I did there. I did arctan of 1 is pi over 4, and I forgot to divide by 2, so I ended up with 0, which is obviously incorrect. So yep, that improper integral done. As I said, just do your limit at the end, because some people say, oh, just put your limit at the very start next to your integral sign, but then you have to follow that through in every step, and it's just going to waste time. So don't do that. Final question on section A is question 7, which is polar coordinates. A curve has a Cartesian equation x squared plus y squared all squared equals 2c squared xy, where c is a positive constant. Question A says show that the polar equation equals that. So we know that if I draw a right angled triangle here, imagine this is our line in polar, this is r, this is theta, that's going to be y, because, well, it's the vertical height, that's going to be x, because it's the horizontal height. So r sine theta equals y, r cos theta equals x. Now, you'll probably remember those, but just off by heart, and also x squared plus y squared equals r. You'll probably remember these off by heart, but just in case you forget, draw sort of like you would with complex numbers on an Argand diagram, a line coming from the origin, and then draw the theta to the positive x-axis, and then your change in horizontals x and your change in verticals y, and then you can just derive all this. See, in case, obviously, because it's not the phone booklet, you forget. In case you forget, so r to the 4, if we're actually evaluating this question, r to the 4 is going to be equal to 2c squared, and then r sine theta times r cos theta. So we can then say that r to the 4 over r squared equals 2c squared sine theta cos theta. And then from A level we know that this is equal to sine of 2 theta, because that's the sine of 2 theta identity from the double angle formulas. I think you can get that from double angle formulas. Yeah, because you can... Hang on, wait, I'm actually going to... Wait, how do you actually derive that from double angle formulas? Hang on, just a quick tangent. Sine 2 theta equals sine theta cos theta. Oh yeah. Okay, yeah. Sorry, that's my fault, because this 2 as well. This 2 is part of the identity, because you add them together, so... Yeah, so 2 sine theta cos theta equals sine of 2 theta. So r squared equals c squared sine of 2 theta. Because sine of 2 theta equals 2 sine theta cos theta. Right. So, and there's a little bit called symbol there. If you didn't know, this is therefore, this is because that could save you a bit of time in your explanation as well. A lot of people know this one, but I don't see as many people using that one. But yeah, that can mean because, which can come in handy. This is a sketch question, right? Yep, sketch the curve r equals c root sine 2 theta and r equals minus c sine 2 theta for 0 theta pi over 2. So I'm going to redraw this actually. So most of you, I will guess, hopefully have a graphical calculator, and we'll just put this in your graphical calculator just to save time. However, assuming you don't, it's still fine. This will only take you this could still only take you like a few minutes even without one, maybe even faster if you know what you're doing. So let's just think. So sine of 2 theta, our sort of critical values you want to look at are 0, pi over 4, and pi over 2, right, for the range we have. So 0, well, sine of 2 times 0 is just 0, so that's just going to be, r is going to be 0. When theta equals 0, this is theta equals 0. This is theta equals pi over 2, I should probably say. And then if we look at pi over 4, that's when we're going to get sine of 2 theta is going to be equal to sine of pi over 2, which is going to be equal to 1. And so pi over 4 is around a 45 degree angle, right? So we can probably say that's going to be around there. And then in between this range it's going to curve, since we're talking about, well, sine, which is sort of like wavy, right? It's oscillating, it's not just a straight line. And yeah, we can draw this back to 0, since if we evaluate sine of 2 times pi over 2, which is what's given theta equals pi over 2, we will get 0. Sorry, 0. So this is going to go back to 0 after it reaches its maximum. And then for negative c sine 2 theta, we're just going to get that in the exact opposite direction, so it's reflected in the y equals x. And that is because that's kind of a bad diagram, but I think that would still get full marks. Just if you didn't, make sure you use pencil and just rub it out. Remember, c is minus, that's c, and that's minus c. The reason it inverts around the y equals x is because you're going to get the same. You're going to get the same values for root sine 2 theta, but then you're going to get that negative c, which is then going to flip your r. So and remember, r is equal to like the x squared plus y squared. No, wait. So yeah, that negative C is going to flip its direction, since your R is going to become negative, and for a negative R, it's going to go, the change in X and the change in Y are going to be in the opposite directions. So you're getting at it flipping around the line Y equals X. So 7C is going to be a polar integral, and this is in the formula booklet, so I'm just going to state it. We're going to get a half the integral of c squared sine of 2 theta, which is half r squared, half times the integral of r squared d theta. That's not meant to be a squared, that's meant to be a 2. And so we can just say this is c squared over 2, the integral of sine 2 theta d theta. And if you're wondering, I'm getting this from what r was equal to. R squared was equal to. R squared was c squared sine 2 theta, which was stated in question A. And then we can say this is just going to be equal to c squared over 2, and then brackets there. Now we use reverse chain rule. So if we want this to have a coefficient of 1 there, we need its integral to have a coefficient of a half. So it's going to be negative a half cos 2 theta. And if you wanted to check, we could do d over dx negative a half cos 2 theta, and that would give us 2 times a half sine of 2 theta, which would equal sine 2 theta. And the derivative of cos is derivative of negative cos is sine, since the signs flip. And then our range, which I should have actually stated earlier, was pi over 2, 0. Since we're just doing for one loop, the region enclosed by one loop. Pi over 2, 0. And so this is going to give us c squared over 2, and then 2 times pi over 2 is pi. Cos of pi is minus 1. Minus 1 times minus a half is just going to give us a half. Yeah, a half. And so, sorry, it isn't there. And then cos of 0 is 1. So there we just get plus a half. And then so yeah, we're just going to get c squared over 2, which is our final answer. And that is section A fully done. So yeah, that was quite easy. Section A is usually easy. Like, again, you'll usually find yourself getting through this very fast. It'll give you a bit of a confidence boost, hopefully, and remind you that you can do this. You can get through this paper. However, it does get harder from here. You really want to be aiming for full marks in this section. It is quite easy to make mistakes, especially because it's the start of the paper. However, a lot of this stuff is just, if you've revised the content and revised the spec, you should be able to get these questions every time. Anyway, I hope you enjoyed the video. I hope it helped. Like it if it did help, and I also appreciate if you could subscribe to my channel. And yeah, I'll see you guys in part 2 for section B.